If you haven't subscribed, ensure you do so. Two train whistles have identical frequencies of 1.8 times 10 to the power 2 Hz. When one train is at rest at the station and the other is moving nearby, a commuter standing on the station platform hears beats with frequency of 2.00 beats per second when the whistles operate together. What are the two possible speeds and directions that the moving train can have? Right, so they want us to find the two possible speeds and direction that the moving train can have. So let's look at the picture of this, or the diagram representing this information here. Right, so we'll assume that this is train 1, which is stationary. Then this is train 2, which is moving. So this train 2 will assume it's should be moving this direction or this direction. So we now, if this is what we have assumed, we have to calculate the speed if it's moving in this direction, then also speed when it's moving in this direction. Right, so how do we do that? So we have been given the beat frequency there, then we've also been given the frequency. So the frequency of these two trains, they've got the same frequency or identical frequency of this. So let's look at how we can do it. Right, so beat frequency is given by the absolute of frequency 1 minus frequency 2. So this is just the remaining renaming of frequency. You can either use letters if you want, but in this case we have decided to use numbers. So this is the absolute value. Whether it's negative or positive, we'll just get the absolute value, which is a positive. So at this point, they've given us to say the frequency is 2 beats per second. So we'll consider this frequency to be positive. So when we do that, when we consider the frequency to be positive, we'll substitute where there's a beat frequency, we'll substitute with 2, like we have done here. Then frequency 1, they've given us to be 180. So we have substituted here. So in short, 1.8 times 10 to the power 2 Hz, it's just the same as 180 Hz minus frequency 2. So the frequency 2 is the one we want to find. So when we remove these the absolute, we will remain with this. Right, so we collect the like terms together. So this, when it goes to the left hand side of this expression, it will become negative, which is here. So when we say 2 minus 180, we are getting negative 178 is equal to negative frequency 2. Right, so when you divide both sides by a negative 1, we are getting frequency 2 to be 178 Hz. So it's one of the frequencies which is here. Let's also look at if we consider the beat frequency to be negative 2. So when we consider bit frequency to be -2, we'll substitute in this formula as we have done here. So this is -2, then 180, then negative frequency 2. So we connect the like terms together. This, when this goes to the left hand side of the equation, it becomes negative. So this is the expression we are getting there. So -2 minus 180, we are getting -182 is equal to negative frequency 2. So when we divide both sides with a -1, we are getting frequency 2 to be 182 Hz. So this is the frequency we have gotten. So using these frequencies, we can calculate the speed and direction of the moving train. So first we'll assume the other frequency is 178. Then later we'll assume 182. The frequency we will assume as 182 Hz. So we'll continue using 180 as the frequency of the source. Right, so let's continue. So like we have mentioned, first we'll consider the frequency of the by the observer to be 178 Hz. So this is the general expression. It works in all the problems. So frequency of by the observer over velocity plus velocity by the observer is equal to frequency by the source over velocity of sound in air minus velocity by the source. Right, so what is the frequency by the observer? So like we have mentioned, we are assuming that the observer was observed this frequency 178. So we assume as our observed frequency to be 178 Hz. So you advise that you also include units when writing. Then the speed of sound in air, we are going to assume to be 343 meters per second because they have not specifically stated the speed of sound in air in our question. Like we have mentioned in our previous videos to say, if they have not given the speed of sound in air in the question, then we have to use 343 meters per second. So this observer is stationary, so the velocity is 0 meters per second. Then the frequency of the source, we have said it's 180 Hz. Then speed of sound in air, we have mentioned 343. Then so here at this point, it is very important to pay particular attention here. So when we look at the value of the frequency by the observer, it's smaller than the frequency of the source. So we have if we recall in our previous videos, we have mentioned that when the source of sound is moving away from the observer, the frequency reduces. So in this case, we can detect that the observer is the source of sound is moving away from the observer. So when the source of sound is moving away from the observer, the velocity of the source becomes negative. So this is the negative we have written here. So mathematically, when you multiply a negative and negative, you get a positive. So we can continue. So this is what we have gotten here. So at this point we can do a cross multiplication. So when you multiply 343 and this, we are getting 61,740. Then when you multiply, so when you're multiplying this and this, you make sure that you write this in brackets so you can multiply. So 178 multiplied by 343, we are getting 61,054. Then when you multiply this and that, we are getting 178 Vs. So Vs is velocity of the source. So at this point, we correct the like terms together. So this goes to the left hand side and becomes a negative. So this is what we are getting here. Then when you subtract, you are getting 686. So you divide both sides by 178 as we have shown here. So when you do that, we are getting the velocity of the source to be 3.853932 meters per second. So we can write this in three significant figures to be 3.85 meters per second away from the station. So it's very important to pay particular attention to such terms. So let's also look at when we consider the observed frequency to be 182. So when the observed frequency is considered to be 182, so we will continue using this formula. Then, so I'm sure now this is very simple, we'll be quick. So frequency by the observer, we are saying it's 182. Then frequency by the source, it's still 180. Okay, so then speed of sound in air, we said they didn't mention in the question, so it's 343. Then this observer is stationary, so the speed is so speed of sound in air is 343. Speed of the observer is 0 because the observer is stationary. Same here. So like we have mentioned previously, to say when you look at the observed frequency, this observed frequency is greater than the frequency of the source, which is 108. So we can tell that this at this point the train was moving towards the stationary observer here. Okay, so when we know that when the source of sound is moving towards the observer, the velocity is positive. This is the positive we have written there. So when you solve this positive or negative, when you multiply them, you are getting a negative. So this is what we have gotten here. So when you solve this, mathematically, you get this expression. So at this point, we will get the like terms like that. Then this is negative. So 61,740 minus 62,426, we are getting negative 686 is equal to negative 182 Vs. So when we divide both sides by negative 182, we are getting the speed of sound by the speed of the source to be 3.76923 meters per second. So this can be written in three significant figures to be 3.77 meters per second. So we have said the direction here is towards the station. So at this point, we are done answering what the question required us to do. Thanks for watching. Remember to subscribe to our YouTube channel.